In this video, we'll discuss copy semantics, and that's how C++ manages copying objects. In this first segment, we'll discuss why we have to be concerned with how objects are copied in C++. And to start, we have to consider the difference between a shallow copy and a deep copy. So to do so, let's first consider how we might manually manage memory. So inside main, we allocate a new integer on the heap and initialize its value to 77, and we store the address of the memory on the heap in our integer pointer p. Now, we want q to be a copy of p, whatever integer p is pointing at. But you'll notice that we have our integer pointer q, and we just copy the address of p into q. As a result of that, as you can see, we have p and q both pointing to the same memory on the heap. So even though initially q has the value 77, as does p, because it's the same integer, once we overwrite the contents that p is pointing to, which is dereference star p is dereferencing that pointer to write to the memory on the heap for that integer. We write 88, so now p's value is set to 88, but because q is pointing at the same place, they are both pointing at 88. This is not what we want. We want q to still have the value 77. So this is called a shallow copy, when you just copy the address of one pointer to another, but you don't actually copy the data to which it's pointing. In contrast to that, I'm going to show you what a deep copy does. For a deep copy, we would actually allocate two integers, as we can see in main. So in the first statement, once again, we allocate our integer on the heap, initialized to 77. We save its address in the integer pointer p. And then we allocate a second integer on the heap. We store its address in the pointer q, and we initially set its address to 77. So here, when we first do these two steps, we'd have both integers set to 77. But then on the third line, we change the integer that p is pointing at by dereferencing it. That's a star p, and we set its value to 88. You can see this is an example of a deep copy because we have two separate integers on the heap, and you'll notice that q's value is still 77, whereas p's value is now set to 88. So that's what we mean by a deep copy. A deep copy is when we not only copy addresses, we actually copy the memory to which the pointers are pointing. So that's a deep copy. Now, it turns out that smart pointers, and in particular unique pointers, can save us from this. With a unique pointer, it's not possible to make a shallow copy. And the reason for that is that we cannot copy or assign unique pointers. So only one unique pointer can keep track of one physical address. So it wouldn't be possible just to copy over p's address to q and assign where their p and q are both unique pointers at this point. It will not even compile, so that shallow copy is not even possible. And it lends itself very naturally to what we want with the deep copy. And precisely what I mean by that is here, we can declare our unique pointers p and q, and we will make our integers on the heap and initialize them. So in this case, when we call make unique, it actually allocates the memory on the heap and creates the unique pointer, which is keeping track of the memory that we just allocated on the heap. So for example, when we declare a unique pointer to an integer p and call make unique int 77, we create an integer on the heap. It's initialized to the value 77, and the unique pointer keeping track of that memory on the heap is stored at p. Similarly, when we want to make a copy of the value in p, where p is pointing, we can call make unique again to create an integer. Here you'll notice we're dereferencing p to get the value that is stored in that integer to which that unique pointer p is pointing, and we store that unique pointer to our second integer on the heap in the unique pointer Q. Finally, we update P by dereferencing the unique pointer P and setting the value to 88. So here, once again, we have a deep copy using the unique pointers. Now, why is this a concern for C++? Is that it turns out by default, assignment and copying of objects in C++ is done by a shallow copy. This is just an element to element copy from the source class or struct to the destination struct or class. So as you can see in the snippet of code we have here, we have a student struct which has an array of chars for the name, an integer for ID, and an integer for major. And inside of main, we declare two student structs, S1, S2. We set the name of the first to Bill, the ID to 5, and the major to CS. And then we just do a copy from the S1 object, which is named Bill, to the S2 object student struct. And when we do that, you'll notice that an element by element copy is completely fine. However, what we're going to be focusing on is what happens if this default shallow copy is not fine. So for example, when we have memory on the heap, we don't want our objects pointing to the same memory on the heap. So that's what we're going to be working on. How can we actually write our own copy constructors and copy assignment operators when we don't want them pointing to the same memory on the heap?